has started. So as you mentioned, we learned the torque couplers and the speed couplers, and we needed these torque couplers and speed couplers as a part of our parallel hybrid electric vehicles. And you are going to see that we are also going to use them in the parallel and series hybrid vehicles. Previously in battery electric vehicles or series hybrid electric vehicle, we didn't need any torque coupler or speed coupler. So these torque couplers and speed couplers are two input and one output, and the input and output can change, of course, devices where we use them to connect our power sources in parallel or in series, as we are going to see in the next. And so far we learned about the parallel hybrid electric vehicles with torque couplers, and we also learned about parallel hybrid electric vehicles with speed couplers, or this is what we are going to do today. And finally, we will have a look into the parallel and series hybrid vehicles. So far, I will come to the slide so you will see where we left. So the last type of the vehicle we checked was the parallel hybrid vehicle with the speed coupler. Earlier than that, we learned that parallel hybrids with torque couplers. And before we continue with the other type, I just want to show you another type, which is the parallel hybrid with both torque coupler and the speed coupler. So it means that in the electric vehicle or in the electrified vehicle, we are going to have both torque coupling and the speed coupling. The last vehicle that we see previously was just had the speed coupler, and we discussed its operation. Now, in addition to the speed coupling, we are also going to add a torque coupling to our vehicle. And it is going to be still a parallel hybrid. Parallel hybrid means that the engine can just supply tractive force to the wheels alone. The electric machine can supply tractive force to the wheels alone, or they can operate at the same time. So this is the definition of the parallel hybrid. And in this case, as the title suggests, we are going to have a parallel hybrid with both torque coupler and the speed coupler. Maybe it is a good exercise to start with identifying where is the torque coupler and where is the speed coupler. So here, I think you should, at least when you study, you will see that this is our planetary gearbox, and planetary gearbox is the speed coupler. Speed coupler means that speeds are going to add up and the torques are going to have a fixed ratio. And this is the speed coupler device, which is a planetary gearbox. And here you see there is one gear and another gear. They are just, one gear is connected to the shaft of the engine if clutch 3 is engaged. So this clutch 3 makes sure that this ring or this gear is rotating with the engine shaft. And here we have also another gear connected to this gear, which is connected to the electric machine shaft. And this part is going to be the torque coupler. So this is the basic gearbox or gear set that you know, two gears connected to each other. In addition to that, we have a clutch so that either this gear is rotating with the internal combustion engine shaft, or it is not rotating with the internal combustion engine shaft. So this is the torque coupler part, and this is the speed coupling part. So if we start with the torque coupling mode, here it is explained how the torque coupling works, and here it's explained how the speed coupling works. But of course, since it is a parallel hybrid, we also need to have this just engine traction, where the power is going to come from the internal combustion engine, and where we are going to have also, maybe I just write it here, since it's a parallel hybrid, we can talk about the other modes later. So there's going to be a first mode, which is going to be internal combustion engine alone traction. Then the second mode is going to be electric machine alone traction. And then we are going to have the hybrid mode. And since we have both the torque coupling and the speed coupling, this hybrid mode is going to have two different options. The first one is going to be the torque coupling mode, and the second one is going to be the speed coupling mode. So in this slide, you are explained how the torque coupling mode works and how the speed coupling mode works. But maybe before that, let's have a look at the internal combustion engine alone traction, the first mode. So the power has to come from the internal combustion engine from this side. So let me zoom in so you see better. So the power has to come from the internal combustion engine and it has to go to the shaft. The shaft is connected to the carrier, so which was shown earlier with green. So, and this is the only connection to the shaft. So it means that the power has to go through the planetary gearbox. And in this case, the engine shaft is connected to the sun. Engine shaft is connected to the sun. Then our sun is going to be the input. Our carrier is going to be the output. Since the engine is just going to operate as its own, then it means that the ring has to be stationary in this case. So to keep the ring stationary, lock 2 should be locked, or I can just write, actually you can understand what has to be the case. So the ring has to be stationary. So it means that the lock 2 is locked. And sun is going to the, so the internal combustion engine is going to the sun, connected to the sun, and the carrier is connected to the shaft, or to it, eventually it is connected to the wheels. And in this case, this clutch is not engaged, clutch 3 is disengaged. Clutch 3 is disengaged. And it means that even so, this is not connected to the shaft. And what we know is input is going to be the sun, output is going to be the wheels. So we can just supply power to the sun and we can get the power from the wheels. So this is going to be the internal combustion engine alone traction mode. So when we want to have the electric machine alone traction mode, in this case, the power, again, the output is always the same. The carrier is going to be the output because this is connected to the wheels. This is the only mechanical path that's connected to the wheels. In this case, the motor is going to be connected to the ring. So this clutch 2 has to be engaged and the motor should be connected to the ring. And eventually with some gear ratio, it will be connected to the ring. Here I can just write EM is connected to the ring. So it is connected to the ring via this clutch. Clutch 2 is engaged. Clutch 2 is engaged. And then we want the sun to be stationary. Sun shouldn't be rotating. And this locked 1 is going to be engaged. Sun stationary. So it means lock 1 is locked. And of course, what is happening to this engine, you can just get rid of it by just taking it clutch open or disengaged and so on. So it means that in this case, the power is going to come from the ring and the sun will be stationary, then it will be transmitted to the carrier, then the wheels are going to rotate. So this is going to be the internal combustion engine alone mode and electric machine alone mode. So you need all these locks and clutches to be able to realize those modes. And on top of that, we have the hybrid modes, which are shown here. So the first hybrid mode is the torque coupling mode. Second hybrid mode is the speed coupling mode. The first and second, it doesn't matter. You can just call it any way you like. And in this case, what we know is the torque coupling is going to work. So we need to use the torque coupler in the torque coupling mode. And what we know is we have just one connection to the wheels, which is going to be the carrier. And maybe I just delete these. And what it says is lock 2 is locked. So the ring is stationary. We are not going to use this path. The clutch 2 is disengaged. Clutch 1 and clutch 3 are engaged. So this path is engaged. So the engine is going to rotate the transmission. Transmission is going to rotate the shaft. And this shaft is going to be engaged to this gear here. Clutch 2 is disengaged. There won't be any transmission. There won't be any connection to the ring. And lock 2 is locked. So it means that ring is going to be stationary. And in this case, what is going to happen is, maybe I just add another one, or here I can write. In the torque coupling mode, the ring is going to be stationary as we have written here. So it is great and I can see it also what is happening here. So the ring is going to be stationary and all the power is going to come from the sun. Input is going to be V sun is going to be our input, and the sun is going to have connection to both to the engine, internal combustion engine, and plus the electric motor. So the torque coupler is going to be used so that the sun is going to be rotated, and our output, there is one output in this configuration, is going to be a V carrier. And both the electric motor and internal combustion engine is going to drive the sun in this setting when we use the torque coupling. And this is used when we had some equations over here. Anyway, so and we use this torque coupling mode when we have the low speed. It is actually what is set in the book. And I also prepared the equation, so I can just write here the equation for that. We see the carrier speed is going to be NR plus NS times the omega S. So by adjusting the speed of the sun, we can control the speed of the carrier, and speed of the sun is related to speed of the internal combustion engine. And here in this mode, what I know is, since it is the torque coupling mode, the speed ratio of the electric machine and the speed ratio of the output of the transmission is going to be fixed, and they are going to be related to the sun. So that was the first part where we use the torque coupling. And in the second part where we use the speed coupling, in this case, this part is going to be used. So the torque coupler should be disengaged. To be able to disengage the torque coupler, we need to just disengage clutch 3. So this gear is not connected to the internal combustion engine shaft. And clutch 1 has to be there. We are going to use the engine, and clutch 2 should be there because now we are going to send electric machine power via ring. So the clutch 2 means that electric machine is connected to the ring. Of course, via some gear ratio, it is connected to the ring, and internal combustion engine is connected to the sun, and lock 1 and lock 2 is released. It means that both the sun and also the ring are free to rotate. So Vs not equal to 0, this is what it means, and V ring is not equal to 0. In this case, all the parts are free to rotate. The Vc was not equal to 0 because our device has to be driven, and our Vs is not 0 and Vr is not 0. In this case, what we know is output is going to be, maybe speed coupling, I just write it here. Output is going to be Vc, again, this is the output that we know. And Vs is going to be connected to the internal combustion engine, and V ring is going to be connected to the EM. So internal combustion engine plus transmission, of course, not directed to internal combustion engine. There is going to be some, at least there is some transmission here. And the ring is connected to the electric machine plus some gear. not electric machine is not directly connected to the ring, but there is a gear and the clutch is activated. And in this case, we can also write the same equation. We know that VC is going to be the output, and we are going to have some VR plus, we are going to have something from the VS. Here it's going to be an R plus an S, and R plus an S. Let me see it. These are the equations that we already seen earlier. This is going to be the NS. So when we do the speed coupling, both the sun is going to have a finite speed and the ring is going to have a finite speed, and the carrier speed is going to be an addition of those. And if you know these, it means that we need to have a fixed torque ratio between the sun and a fixed torque ratio between the ring gear. And this is going to be the speed coupling mode, where the speeds are going to add up. And in the torque coupling mode, we were adding the torques of the system. Maybe in the torque coupling mode, the torque of the electric machine was adding up the torque of the internal combustion engine. Now in the speed coupling mode, the speeds are adding up. And in the book, it was said that this was good for the high speed operation, so that the electric internal combustion engine can operate at an optimum speed. And the torque coupling mode was good for the low speed operation. So when the omega S is low, we would like to have the torque coupling. When omega S or let's say it other way around, when my video is gone. Anyway, I turn it on. I will turn it on soon. So if the VC is low, then we want to have the torque coupling so that VS and VC has a fixed ratio. If, omega. If the omega C is high, then we want some speed addition, and some part of the speed is going to come from the ring, and the other part is going to come from the sun. So it means that this is used for low speed, and this is used for high speed. So at high speed, we make speed addition. At low speed, we make the torque addition to get a high torque. So this was the parallel hybrid. We talked about the IC alone mode and electric machine alone mode, and also two hybrid modes where we had to distinguish between the torque coupling and the speed coupling. Okay, my video is back. Now, it is time to learn something a little more complicated. We learned the parallel hybrids with torque coupling, parallel hybrid with speed coupling, parallel hybrid with both torque coupling and the speed coupling. Now it is time to continue with parallel and series hybrids. So it means that we are going to have a configuration. This configuration should be able to work as parallel hybrids, and depending on the case, it should also work as a series hybrid. So this is the configuration, and this is a very famous configuration. This is the configuration of Toyota Prius, what they have, and this is also called a power split hybrid. So let's first understand the series path and the parallel paths. Maybe it is good to remember the series hybrids. In the series hybrids, we need to have, let me put here some slides. So since it is a parallel and series hybrids, let's try to understand what is the parallel path and what is the series path. In a parallel hybrid, we know that we need to have internal combustion engine, and we are going to have electric machine. Then we are going to have a mechanical coupling so that they are going to drive the shaft. So they can either drive it alone or they can just drive them at the same time. On the other hand, in the series hybrid, what we have learned is we are going to have an internal combustion engine. Of course, there is going to be some fuel input. This internal combustion engine is going to rotate a shaft. From the shaft, we are going to have a generator. Generator is going to create some electricity. This electricity is going to be stored in the batteries. Here, I'm going to have an AC to DC converter if this generator is a three-phase machine, and they are usually three-phase machines. And I can also use this battery power or directly from this path. Let's save. So I need to put here another DC to AC so that I can drive my traction motor, electric motor, traction motor. So it means that in a series hybrid, I need to have internal combustion engine plus the generator. And I also need to have the electric motor. And these are not going to be mechanically coupled, but they are going to coupled via the batteries or from the electrical side. So this is the need for the parallel hybrid. And this is the need for a series hybrid. So it means that if we want to have both the parallel hybrid and the series hybrid, it means that we need to have both internal combustion engine, then electric machine. Then we need to have a generator and also a coupling. So if you see all of them in one configuration, so it means that we do have a parallel and series hybrid. And let's try to identify all these components in this parallel series hybrid configuration. Here is the engine, internal combustion engine. Here is the traction motor. Here, there we have some couplings. We will identify what are those coupling in a short time. And in addition to what we have seen in the parallel hybrid earlier, we also have a generator. So this is also an electric machine. And in this configuration, this generator is called generator motor 1, and this is called generator motor 2, as we are going to see in our slides, and it is also shown here. So we have the generator and traction motor. It means that we have two electric machines and one internal combustion engine. On top of that, we have here the planetary gear set. The carrier of the planetary gear set is connected to the internal combustion engine shaft, and there is no transmission after the internal combustion engine because this generator is going to help us with adjusting the speed of the internal combustion engine. In the previous configuration, we did have a transmission because that we wanted to make sure that the internal combustion engine was operating in the right speed range, and it was also able to operate at a right gear ratio. But this was the transmission. But in the parallel series hybrid, we don't need this transmission. So more or less, you can see that we are replacing this transmission with this planetary gear set plus the generator. Generator is going to help us to adjust the speed and the torque of the internal combustion engine, as we are going to learn. So the engine is connected to the carrier. This is this connection. So as we discussed earlier, this is a planetary gearbox. This is sun, this is carrier, and this is ring. So internal combustion engine is connected to the carrier. So the generator, actually it can also operate as a motor, but assume it's most of the time it's going to operate as a generator. Generator is connected to the sun, and it is called MG1. The generator is connected to the sun, and the electric motor, so GM2, the traction motor, let's call it the traction motor. It's a nice blue here. Traction motor is connected to the ring, but it's not directly connected to the link, but there is some gear ratio between the traction motor and the ring, but it is somehow connected to the ring. And this electric machine has also a direct connection. If we didn't have any of those, it also has a direct connection to the wheels. Its direct connection maybe can be shown it here. It's going to have a direct connection with the wheels. There's going to be a gear ratio. So that looks like a pulley assembly, or it can be a chain, but it looks like a pulley. So if the traction motor has some ratio and some speed, we are going to have some gear ratio between the wheel speed and the traction motor, but it is directly connected to the wheels as well. So here what you see is a torque coupling device. So the torque of the traction motor and the torque of the ring is coupled. So in this torque coupling, maybe we write what is coupled, which torques are coupled. This torque coupling is going to couple the torque of the traction motor. We are going to just call it traction motor. And it is also coupling the torque coming from the ring, the torque of the ring, and it will connect it to the shaft or the wheels. And here, this planetary gear unit does not have a direct connection to the shaft, but it is connected to the shaft via the ring and later via this torque coupler. But it has one connection. Sun is connected to this generator. Carrier is connected to the internal combustion engine, and the ring is connected to the shaft via this torque coupling device. Okay, so in the next slides, we will going to look into different operating modes, but maybe first we try to understand what is the series path and what is the parallel path. So here you see the same thing again. And this device, which we have the planetary gearbox plus the generator, and of course this generator is very important, is connected to the battery. Maybe we put it is connected to the battery, and same battery is connected. Of course, we have the converters. I'm just going to draw in. That's connected to the MG2. And this device, which includes the planetary gearbox, MG1, and the battery. If you don't have the battery, it won't work. If we have the battery, is called an electrical variable transmission. And since we have this electrical variable transmission, then we don't need to have an additional mechanical transmission just after the engine. And this is called a power split device. So we are trying to understand why we call it a power split device and what is the use of it. Here you see again the ring here. This is the planet and the carriers of the planets. And this is the shaft which is connected to the this carrier, and we are going to have the sun. Sun was connected to the MG1. Here planets are connected to the internal combustion engine, and ring is connected somehow to electric machine, and then it has also connection to the wheels. So if we just look at the series path, what we see is so internal combustion engine can run this carrier, and then the ring can be fixed, or maybe it is freewheeling. It can also have it can be stationary either. From the carrier, we are going to go to the sun. From sun, we are going to go to the generator. The generator is MG1. And from generator, we can go to the batteries. I need to write it correctly. From the generator, we can go to the batteries, and from batteries, we can go to the motor, traction motor, And from the traction motor, we can drive the wheels. So it means that the system does have a series path: internal combustion engine, generator, batteries, and traction motor. Then we can drive the wheels. It does also have the parallel paths, as we are going to discuss later. So I'm also going to solve an example on how these paths will operate. But this is important to just repeat what was the series path. And here also maybe we try to first understand by this torque coupler device. What you see here, the torque coupler. I have just defined some ratios, gear ratios. I think that was one of the reports from the Oak Ridge. I was able to find these ratios, but maybe in the newer versions, newer generations, these ratios will be different. We are just trying to understand how the system works. There are two ratios defined. The gear ratio from GM2 to ring is one ratio, and the ring to the wheels is the other ratio. If you multiply them, GM2 to ring with the GM ring to wheel, of course, you will get a ratio. Maybe it is more useful in some sense. If you multiply those two, the ratio, the gear ratio, GM2 to wheel. So this is the ratio that it is connected to the wheels. And as you see here, this is a pulley assembly. And this is the torque addition. The torque addition can be seen here. The torque of the traction motor multiplied by the gear ratio from this shaft to the ring, plus the torque of the ring. They are going to add them up. This is a torque coupler, is going to be equal to the torque at the wheels multiplied or divided by the gear ratio between the ring and the wheel. Of course, you can define different gear ratios and you can just write the same equations. So these are showing the governing equations of this torque coupler part. So the wheel speed is related to one-to-one related to the GM2 speed, and GM2 speed is one-to-one related to the ring speed. And here we have the torque addition. The torque can come only from the GM2. So this is what it says. If you want to get some torque at the wheels, maybe I just write it there. TR to be bigger than 0. If you want to get TR bigger than 0, you can just have torque due to the GM2, the direction motor, or you can have just the torque due to the ring, and the ring torque is going to come, it may come from the engine or from the other sources, T-ring. Or you can have both of them, TGM2 plus TR. So this is the electric machine alone mode. This is maybe the generator alone mode. Maybe the electric machine is also helping that, but maybe this is the GM alone mode, and we can have both of them. So this is where you see the parallel path, so they can operate at the same time to drive the wheels. And also let's see the equations of the speed coupling parts. So I just put here the equations for the speed coupling, but of course the outputs and inputs are different in this case. I just copy pasted the equations that we have driven earlier. In this case, we are going to have GM2 connected to the ring. This is the ring speed. Engine is connected to the carrier. This is the V carrier. V ring. Let me save it. And this is GM1 is connected to the sun. This is going to be V sun. So this V ring is the total of them because there is a gear ratio between the electric machine, the traction machine, and the ring. So this is going to be V sum. So this is how the speed addition works. And if we have a speed addition, the torques have to have a fixed ratio. Whenever we want to have a non-zero torque from the electric machine, it means that the engine should have also a non-zero torque with this ratio. And the generator has to have a non-zero torque. So this is the cost of having speed addition. So these are coming from these equations. So in the next slides, I just want to discuss with you the different operation of that, like as we have done earlier. So this will come in this slide, like the pure electric mode. I forget the pure engine mode. Let's come here and delete those. I hope that it comes in the next slide. So the pure electric mode, how the power will flow, and later we are going to look into the other modes. Save. And the other modes are going to be pure engine modes and also some battery charging modes and so on. In the pure electric mode, it means that GM2 is going to operate as the traction motor. And this is what's done at low speeds. So the GM2 is going to be used as the traction at very low speeds. In different previous models, there's the maximum speed that the GM2 can run the system is going to be different. It's going to be different in different models of the previous. But what I know is this GM2 is the machine 2. GM2. GM2 is going to supply torque. And as you maybe remember, so here GM2 was connected to the ring and it was directly coupled to the wheels. So this is going to be this mode. But of course, what we know is if GM2 has a non-zero torque or non-zero speed, all these things are also coupled to that. For example, when you see here, if GM2 is rotating it has a torque, and if it has a speed, this part does not need to create any torque. But this part has to have a fixed speed. It has to rotate because it's this is a torque coupling. To have a non-zero torque here, these speeds have to have a fixed ratio. In this case, what we can say that GM2 speed, GM2, the speed and torque is not going to be zero. They are going to be different. And the speed is going to be directly related to the speed of the wheels. And the torque is going to be directly related to the torque at the wheels. But on the other hand, since internal combustion engine, and there's going to be GM1. Since the ring has to have a finite speed, this means V ring is not allowed to be zero, but torque coming from the ring, it can be zero. It doesn't need to generate any torque. It can be zero. Since V ring is not allowed to be zero, it means that the speed addition part, what we have seen earlier, so V ring was equal to some constant, let's call it K1, plus Vc, and minus another constant K2, it is shown here, and Vs. If V ring is non-zero, it means that one of these systems have to have a non-zero speed. And this is at the starting, usually it is done at the starting. And it means that if we start the internal combustion engine, we want it to be idle. This is what is explained here. So internal combustion engine is idle. So it means that its speed is going to be 0. If this part is 0, we have no other chance, but we need to make sure that this sun or the generator is going to rotate. And it means that V sun cannot have a 0 speed. So it has to, the ring speed has to be balanced. So in this case, what we do is we keep planets steady. We rotate the ring. Ring has to rotate because it is directly connected to the GM2. And to be able to compensate it, the sun has to be rotating too. And the system, this is always used as the startup. And here, what you can see, there used to be animation, but now this animation doesn't work. So if you can make it work, please let me know. It was a very nice animation. But I had the screenshots from the last year, so that's something at least good. So these are the speeds of the traction motor, speed of the internal combustion engine, and speed of the generator. And as you see, my PowerPoint is unstable. Anyway, let's see what will happen. So here, if you want to have a non-zero speed from the traction motor, the internal combustion engine to be at 0 speed, then it means that MG2 has to have a negative speed. And the maximum speed in which the electric traction motor can operate depends on the maximum speed of the generator when the internal combustion engine is going to have a 0 speed. And this is the maximum speed at which we can do the pure electric drive. Pure electric drive limit. And its speed is limited by the maximum speed of the generator. And for example, in this model, the speed of the generator maximum speed is minus 6,500. And if the internal combustion engine has to be kept stationary, it means that MG2 can have maximum speed of 2,500 RPM, which will correspond to 42 miles per hour. So actually it's a very fast speed. I don't know if they really use it, because to have it in kilometers per hour, you need to multiply it with 1.6. So it is not a very low speed. So this pure electric drive speed is limited by the maximum minus speed of the generator. And in this equation, you can also see that there should be a minus. This is what we do at the starting. So the battery power is depleting, battery energy is depleting, and the machine 2, GM2, is driving the wheels, but the sun should have, it should freewheel with the GM2 in this case. Okay, let's look also this case, then we will continue from here on Thursday. The second mode is the pure engine mode, and there are two versions of the pure engine mode, and the third one is the hybrid mode. In the pure engine mode, we know that the power has to come from the planets. So the torque of the engine will come to the planets, torque engine bigger than 0, and it has to come to the carrier. So this is the carrier where the planets are connected. It's called the carrier. Then the first option is the GM2 is going to freewheel if GM1 speed is 0, because it has to be like that. Otherwise, it cannot work. Let's maybe discuss that and we can stop this. Let's discuss the first mode. Again, I will just put here the ring, carrier, and the sun. In this case, the power is going to come from the carrier, and it is going to be delivered to the ring, because ring is where it is connected to the wheels. And the ring is connected also to internal, so to electric motor, GM2, and assume that this is somehow connected to the wheels. My perfect drawing. So this is somehow connected to the wheels. So if the power is coming from the carrier, and this is going to have a finite speed, so this should be rotated, and this is a torque addition. A GM2 torque is 0. It means that the torque generated by GM2 is going to be 0, but it has to freewheel, so it has to rotate with the ring because it is directly connected to the ring. And GM2 speed can be 0 in this case. If I just write it again, V ring equal to K1 omega C and K2 omega S. In this case, we have this C has a speed and the ring is going to have a speed. And if they are going to have a ratio, we can have GM1, the generator, to have a 0 speed in this case. Anyway, let's stop here because I also want to explain some other modes and maybe also show you this hybrid mode, how their speeds are going to change. We will finish the modes of this series on Thursday, and I'm also going to solve a question because I know it looks weird why we need to do all these transmissions and why do we have all these modes. I will try to explain what is the benefit of using this power split device. And just by thanks to this power split device, we don't need to have this multi-speed gearbox. And just by using the system, we can make sure that the engine can operate at its maximum efficiency points in most of the cases. This is, I'm going to solve an example. So let's stop here because I know that some of you have lectures, so you need to leave. I'm just going to pause or stop the recording.